Welcome back to G Fun Facts Online, your go-to spot for fascinating insights into the world around us. And sometimes, the world long, long ago. Today, we're diving deep into a mystery that has puzzled archaeologists for decades, the case of the missing tin. Not missing as in vanished, but missing as in where on earth did Bronze Age civilizations get it all from? It's a story that's redrawing ancient maps and showing us just how connected our ancestors really were. So why all the fuss about tin? Well, tin is the secret ingredient that transforms copper into bronze. And bronze? Bronze was revolutionary. It was harder than copper, easier to cast, and had this beautiful golden sheen. Think tools, weapons, fancy jewelry. Bronze was the high-tech material of its day, around 3,000 to 4,000 years ago. But here's the catch. Tin deposits are surprisingly rare, way rarer than copper. For civilizations in places like the Eastern Mediterranean and Mesopotamia, which didn't have local tin mines, this created what archaeologists call the tin problem. How did they get their hands on this vital metal to fuel the Bronze Age? For centuries, theories flew back and forth. But now, cutting-edge science is giving us some astonishingly clear answers. We're talking about provenance analysis, basically figuring out where something came from. And the star techniques? Isotopic and trace element fingerprinting. Imagine every tin source has a unique chemical signature, like a fingerprint. Scientists can now read these fingerprints in ancient bronze artifacts and match them to geological deposits. So how do they actually do this? There are two main methods. First, isotopic analysis. This looks at the ratios of different isotopes of tin and lead within the ore and the artifacts. Isotopes are like different versions of the same element, just with a slightly different weight. Tin deposits formed at different times and places have unique isotopic signatures. Lead isotopes are super helpful too, because their ratios can even give a geological model age for the ore deposit, like a birth certificate for the rock. Second, there has trace element analysis. This measures tiny amounts of other elements mixed in with the tin. Different ore sources will have their own special cocktail of these trace elements. Scientists use incredibly sensitive machines, like inductively coupled plasma mass spectrometry, or ICP-MS for short, to detect a whole range of these elements. By combining both isotopic and trace element data, researchers create a really robust fingerprint, making it much easier to pinpoint where that ancient tin came from. And the discoveries coming out of this research? They're mind-blowing. For a long time, everyone thought Central Asian tin, from places like modern-day Tajikistan and Afghanistan, was the main supplier for the Eastern Mediterranean. But recent studies, like those from Heidelberg University, have analyzed tin ingots from ancient sites in Israel, Turkey, and Greece. And guess what? A lot of that tin, dating back to the 2nd millennium BCE, actually came from Europe, specifically from places like Cornwall and Devon in Great Britain. In fact, a brand new study, hot off the press in the journal Antiquity, we're talking May 2025 here, further cements this idea. Researchers used a novel combo of analyses on tin ores, artifacts, and even tin ingots from Bronze Age shipwrecks found off the coasts of Israel and southern France. The result? They could trace these ingots straight back to ores in southwest Britain. This is huge. It means these rich, accessible tin deposits in Cornwall and Devon were fundamental to the spread of bronze technology across Europe and the Mediterranean. Imagine small farming communities in Britain mining and trading tin over thousands of kilometers, reaching major civilizations like the Mycenaeans or those in the Levant. It's like finding out your local village baker was secretly supplying bread to emperors across the continent. These findings are completely reshaping our understanding of Bronze Age trade. We're talking complex, far-reaching routes, likely involving ships sailing the Atlantic coasts and perhaps even river routes through France, connecting diverse cultures way earlier than we thought. Now, this doesn't mean Central Asian tin wasn't important. It likely supplied Bronze Age cultures closer to home, like the Andronovo and the Bactria Margiana archaeological complex, and possibly even some early bronzes in the Near East. The famous Uluburun shipwreck, dating to around 1300 BC, with its massive cargo of tin ingots, is still a hot topic. Some studies point to Central Asia, others to Europe, including Britain. The jury's still out on that specific call, but the plot is definitely thickening. And the science itself is always evolving. Researchers are even conducting smelting experiments to understand if the process of melting down ore and extracting tin might slightly change its chemical fingerprint. This is called fractionation, and accounting for it is crucial for pinpointing origins accurately. Of course, it's not all straightforward. There are still challenges. Sometimes, the chemical signatures of different ore deposits can look quite similar, making it tricky to be 100% certain. Plus, we don't yet have a complete global database of every single potential Bronze Age tin source. And to complicate things further, bronze was often recycled. So an artifact might contain tin from several different original sources, all melted down together. It's like trying to figure out the ingredients of a soup after it's been blended. But scientists are on the case. Future research will keep expanding that database of ore signatures, refining the analytical methods, and analyzing even more artifacts from different places and times. And those shipwrecks? They are archaeological gold mines, or perhaps tin mines in this case, because the ingots they carry are direct evidence of raw materials being traded. Integrating all this scientific data with traditional archaeological evidence and any ancient texts we might have is key to painting an even clearer picture. So the Great Tin Problem is slowly but surely being solved. And as it unravels, it's revealing a Bronze Age world that was far more interconnected, dynamic, and frankly, more surprising than we ever imagined. Tin wasn't just a metal. It was a catalyst for vast trade networks, technological leaps, and the forging of early international relations. Who knew a lump of tin could tell us so much about our ancient past? Thanks for joining me on Fun Facts Online today as we dug into the secrets of Bronze Age tin. Don't forget to like, subscribe, and hit that notification bell so you don't miss our next journey into the amazing world of science and history. Until next time, stay curious.